Om. Om Sagana Bhavatu Saganau Bhunaktu Sakaviryam Karavavahai Tejasvinavaditamastu ma vidvishavahai. Om Shanti Shanti Shanti.
Namaste to everybody. Uh, Today the podcast is by our friend Tency. I know Tency for the last 35 years. In fact, we learned and perfected our ferrocement technology under his guidance. And a few years back, Tency came to Kanyakumari and he saw our work and he complimented us. So we're very, very happy that whatever we learned from him, we could implement it in the field. More than ferrocement technology, he has done a lot of work in many of the technologies. I want our Sanjay Banerjee to introduce Tency before we start the podcast. Over to Sanjay ji.
Namaste, everybody. My pleasure and honor to introduce Shri Baetens Tency from Auroville. Born 26 May 1950, he studied at University of Brussels between 1969 and 1973. He traveled to India first during 1971-72, and his second India journey took place in 1977. He joined the Indian Trail, a section of the alternative youth movement, and traveled through Istanbul, Tehran, Herat and Kabul, through the Khyber Pass, moved through Pakistan to reach India, where his small group was warmly welcomed by a single female border guard who distributed flowers to each one. Mr. Tency says that precious moment of relief felt like escaping a nightmare and arriving home. He has been living and working in Auroville for around the past 5 decades, and he had his first darshan of Mother of Auroville on 5th of March 1972. He started working at the Matri Mandir right from his arrival, and he is co-founder of the Auroville Center for Scientific Research in 1984. Here are some of the ongoing activities under the center. Design applied research in adaptive comfort for tropical dry climate zone of coastal India. Energy, policy research, technology innovations, demonstration projects, applications for renewable energy. Water, resources management, natural wastewater treatment systems, rainwater harvesting, water data collection and analysis, water audits, flood risk assessment studies, mobility, urban land use planning for reducing motorized vehicular traffic through battery operated cycles, mopeds, bikes, and vehicles, regenerative technologies, low energy input, manufacturing equipment with plastic grinders, extruders for recycling plastic waste, plastic processing, large format 3D printers for low cost housing using local natural materials. Welcome once again, Mr. Baetens, Tency, and the floor is yours.
Thank you for the introduction, Sir Sanjay. Indeed, we started as a humble beginning, the Center for Scientific Research in '84, just to, in a very unfriendly environment, to provide some comfort, heating warm water and things like that. Over the many years, we concentrated on the 5 areas, which Sanjay highlighted. And they provided themselves as points where we could do some work in applied technologies. And actually, that became our focal point. We're not doing pure scientific research, but applied scientific and industrial research. And we identify areas where we can do some useful work, not only for Auroville, but for the wider community. Let's go over to the next slide. Images, because they just give an impression about a fairly long journey. In design, what we try to achieve is applied research in adaptive comfort for tropical dry climate. And next slide. The first actually area which we explored fully, and with the help of the International Ferrocement Society based in Thailand, was ferrocement technology. And it really blossomed. We shared that through HUTCO with all the building centers in India, all of them. Next. We tried out the ferrocement in different, not only products, but also on buildings. For example, the buffet walls and the roofing were done fully in ferrocement for the Tibetan pavilion. Next. We built a fairly large shed on the compound of CSR. The person next to me is one of the many mentors, Dr. Chamanal Gupta, who is still with us. Next. That's a view of the shed, 34, 11 meter wide, fully in ferrocement. Next. Then different shade devices for Indian Institute of Human Settlement. Next. We got the COP award a few years ago for a community buildings which are called Human Scape, where we used ram earth together with ferrocement and all devices which could be integrated for sustainable water, energy, and things more. Next. It's not only useful products, but we also applied the technology for sculptures. Next. We step out of design and we enter the area of energy, where quite a large amount of work has been done in policy research, technology innovations, demonstration projects, applications in renewable energy. Next. The first thing were prefabricated biogas plants in the 80s. And we were at a certain period in time, the suppliers of biogas plants for Andaman and Nicobar Islands. They were created, went to Chennai, then on a boat, and then distributed over the islands. Next. One of the major projects was building a solar bowl in Auroville to provide usable steam. This one is for cooking in the solar kitchen. There are 3 or 4 solar bowls in the world. It's a fairly cheap device. The drawback is when there is no sun, you have no energy. And then you have to use a backup system with a generator or a boiler. And then integrating the technology becomes a bit more complex. Next. One of the projects was installing about 8,000 solar panels, lamps, also some batteries in Ladakh during a period of exactly 3 months when the passes were open and when the season was and when the season allowed us to do the transport and the installation. For that one, we received the Ashton International Award for Sustainable Energy. Next. The major implementation at the moment is in the area, especially in the energy sector, of solar panels. And we try to set up a mini grid. Next slide. It shows the evolution of renewable energy for the community, which during the year 1819 was 68%, and during 23 to 24 moved to 81%. The two energy forms are solar panels and wind energy. We operate about 2 or 3 wind generators in the south of India, where the energy is wheeled. Next. A major area of work consists water, which is a very source. It's a dependable source for sustainable development. And we work in water resource management, natural wastewater treatment systems, rainwater harvesting, water data collection and analyzing, water audits, flood risk assessment studies. All the projects started on a very humble beginning and developed as the journey proceeded. Next slide. Water resource management. Next slide. One of the major breakthroughs was in wastewater development, wastewater treatment plants, where we actually used not an invention, but an innovation which we came across within Auroville of a vortex. And it's actually a replication of what happens in a typhoon in nature. A typhoon is destructive, has a huge force. We harnessed it in a closed environment, a smaller environment in a tube, and we channel the water on the bottom, and it swirls, and it makes actually the same design, a miniaturized design as the typhoon structure. What it does is it pushes an enormous amount of oxygen within the passing through water. Next. So we provide small systems from 15 centimeter dia vortexes to 1 meter dia vortexes, which are made in ferrocement. Next. And they are applied on wastewater treatment plants within India and sometimes abroad. This one is a picture of Ramco New Township, Kalvatala in Andhra, where a 500 KLD first phase is working. You see the 3 1 meter vortexes and the 60 centimeter acrylic vortex next to it for the purification of the last stage of the water. Yeah, next slide. This is in Auroville, the residential zone treatment plant for 60 KLD. Next slide. Water security is important, and we try to integrate as much as possible the potential from rainwater and implementation of multi-sourcing. Next slide. We did, in the beginning, a fairly in-depth study of the underlying aquifers. Next. Aquifers, of course, are not property owned. They go over large areas. And whenever the good work is done in one area, it doesn't mean that the area extends a few kilometers further. So it's not really a very dependable, sustainable source of water. Next. We understood that it's important to actually integrate climatic data. So we tried out a lot of weather stations. Yeah. Next. We came back because we had quite a few failures with the weather stations. None of them they provide for a time accurate figures, but then after a while they break down and finding spare parts take a time. So for the most essential water rain measuring, we fell back to actually manual rain gauges. And we do that for about 14 sites over Auroville, and we have a standardized table in which we put the daily rainfall. So we have an overview, a yearly overview, how much rain we receive within our geographical area. Yes, next. It's put on the web GIS interface. Yeah, next. So that it's viewable for a much wider public. We tried and are still busy with trying to do automatic well readings with sensors and a step further transmission of the data, automatic transition. Next. This is how it looks. We have in the well, we have a sensor and then a transmission pole for the data. There's still quite a few problems, teething problems, which we have to solve to do it on a much wider scale. For the 57 wells that we would like to do and measure on a regular basis. Yes. Next. This is how it looks, the transmission. Next. It's all put again on the WebGIS interface website. Next. Interesting data show an rainfall, every rainfall, and how the water level in the wells reacts. Very interesting. Next slide. We did since 2017 an integrated topographic survey and mapping. We do that with DGPS equipment. Yes, next. The survey uses standardized CAD layers. Next. And then we get the result on the maps. A fairly detailed topographic survey with all the trees listed. Next. And the contours gives an idea by the arrows where the water exactly flows in the micro topographic area. Yeah, next. We branched out with a corporate company to starting flood risk assessment studies. And the first one that we took was the Hooghly River watershed. We surveyed the runoff generation for a huge watershed, about 27,000 square kilometer. Then the land use, the land cover, the tides. Next. We did the watershed, the topography, and the soils. It was about a 3-year project, and we have completed it. Next. We step after the design, energy, water, we step to mobility, which is an extremely important part and sector in if we want to do something about sustainability. We chose at the moment to introduce first cycles, then mopeds and scooters, all operated on batteries. Yes, next. We have about a pool of 600 vehicles within Auroville which operate on batteries, and we actually found the key to have a smooth operation of the things. The lithium batteries are not the end of the line. There are quite some issues involved with it also. But we found that if we give regular service of the vehicles, whether it's a cycle, a moped, or a scooter, or even a vehicle, maintaining it is essential. Those cycles are not sold, but you can use them and you pay a monthly maintenance fee, which includes a monthly maintenance part where the cycle is completely cleaned and every broken part is replaced again. And actually that's the key to have a successful mobility program. It's providing a proper service for the vehicle. Next one. Next slide. Yeah. Part of the cycle pool. Yeah. Next. And then we come to one of the later technologies which we are developing, which is regenerative technologies. We try, the first effort was, of course, doing something with the surrounding plastic, the manners of plastic. The product is useful, very useful, but when it's not recycled properly, it becomes a real menace. I mean, when we drive through the villages, the waste of plastic is mega. It's a mega problem, which in a small way we have tried to contribute to something. Next slide. We started with providing training for village entrepreneurship in setting up small-scale wind generators. Next. And then we organized the collection, especially we took an area of the beach front where we collected all the plastic, and we started to manufacture actually the elements which, or the product lines which are necessary for recycling and reusing plastic waste. Next. For example, we make doors, door frames, furniture, and things like that. Next slide. The next effort, which we have completed the first phase, we're now on the second prototype, is a huge 3D printer for actually printing walls and building houses. Next slide. It's an open source. It's not the only huge 3D printer in India. There exist quite a few, but it's the only open source. And these are part of the testing program to make walls, different types of walls, All this small, maybe I'm not too sure, achievements or efforts, that's maybe a better word, are of course sustained by the atmosphere of, and the creative atmosphere of Auroville. It's a relative small community. The major effort that we're trying to achieve, and which is extremely difficult, is to create human unity in an as much as possible diverse landscape, human landscape. And that's what we continue. We are not yet there, far from there, but the major thing is that we keep trying. So the next slide gives you an overview of all the emails and where you can contact the people involved in the different activities. Thank you so much for giving the opportunity, Vasudeva, with your podcast.
Thanks, Tency, for the very nice presentation.
Yeah, thank you, Mr. Tency Baetens, for your beautiful presentation. The entire presentation was of utmost importance to us. And my one query was that you mentioned about the natural way of sewage treatment. Do you use some particular type of plants where the roots carry out this kind of natural treatment, or you use some other methods?
We use another method. We started working with a planted filter, and the drawback about the planted filter was the size that you have to provide for each user. If it goes to, if you have many users, the size becomes enormous. So we knew that this was an issue. The second issue is that the filter material started clogging since quite regularly. And cleaning a planted filter with the filter material is cumbersome, expensive, because you have to do it regularly. And that's why in 2008, we actually stumbled upon the innovation of the vortex. And we found that in a minimal footprint of less than half a square meter, we could actually put a device which treats the water much more efficient than with plants. It was important because if you have a campus and you have space, you don't mind to sacrifice space for doing a planted filter with plants. We use several plants. To come back to your answer, the first one which we use regularly was Arunodonax. Then we even used Canons. Lately, we found that bird of paradise, the plant which thrives quite well in a submerged water environment, does very well. So there are things, but the plant size is okay for limited users. Once you go to community or a cluster of buildings, it becomes quite difficult. And that's where the new innovation of the vortex plant is so reassuring and opens a completely new way of treating wastewater. I will share also with Vasudeva the small video, a very short video explaining the technology of the vortex Devats.
Yeah, thank you.
For Sanjay, what is the capacity? We work from 500 liter for households, and the biggest ones that we did in the vortex Devats at the moment was 1000 KLD, which is, I think, more than 1 lakh, no? 1000 KLD, I can't remember. So that's the maximum size that we do. That's for a fairly large settlement community of people. The thing is, the more clients, the more wastewater users you put together, I have to check how much for that question, how much energy we use. It was at a certain point I could tell you, but now I have to check it back. In such plants, there are usually pumps involved. That's the trade-off. A planted filter goes by gravity, but you end up with a huge amount of space, and nobody in an urban landscape wants to sacrifice that amount of space, prime space for a wastewater treatment plant. So if you can minimize that one, that's an added benefit for wastewater treatment plant. I will share the details of the Vortex Devats. But what I want to say, there are usually 2 pumps. We have in the treatment devices, we have an equalizer tank where you pump the water to the next devices, and then at the end, for running the vortex, you need also a pump, a dewatering pump to channel the water through the vortex. So the trade-off is that instead of by gravity, you use electricity on 2 pumps. Not huge, minimal, but it has to be there. No, the issue is not it's much, much easier to maintain. It's just assuring the flow through the different devices. It explains it very well in the video, which I will share, the YouTube connection. It's low on maintenance, which does not mean no maintenance. Low maintenance does not mean no maintenance. All devices need to be maintained. But compared to membrane technology and things like that, it's huge. In the I think 2014, we set up in Bangalore a fairly big system with vortexes, and then I can't remember, it was about 450 KLD, but then we did a proper calculation with membrane technology, and the maintenance per year for that, I think it was anything between 400 to 500 KL, was about 20 lakh a year with a high-tech maintenance team. For the Vortex Devats, it came to less than 5 lakh, actually 3 to 4 lakh. A huge difference in maintenance cost, but you have to maintain it.
Tency ji, first of all, my pranam, and it's really a pleasure and sincere gratitude for accepting speaking on this forum. I remember way back in 1999, I had an opportunity to be at Auroville for around 2 weeks, where Shri Chamanlal Gupta ji, respected Gupta ji, his wife, and all other colleagues, including you. Perhaps I had met you also that time, and one was bright person called Lamba. I'm forgetting his name, but Lamba.
Hemant.
Hemant Lamba, yes. And he just saw us all the work done by Auroville at their laboratory, what is called the all ferrocement work and other works also. And it was really a treat to be there that time. And I have two parts my questions. One is that regarding the technologies developed by the Auroville, I understand a number of technologies, as you mentioned in your presentation, have come up and they have been perfected with minor details with at the Auroville itself, including FRP or construction technology or water treatment, many others. Some are technologies in real sense, some are the processes, some are the guidelines. How to act on that, that is there. So whether there is a consolidated place in Auroville somewhere you have created where anybody can take up from the can handhold and start working on these technologies based on the information provided at that particular forum. That is there because these I understand nothing has been patented. It is all in the public domain. Whether some consolidation work has undergone or not, that is one thing. Secondly, I think you are here today and we will like to know more about the Auroville life. That really was great and I was completely fascinated that people from 60, 70, maybe more nationalities were made their home at Auroville and they are living. Perhaps now it is third generation or so is there. We like to listen you on the experiment at Auroville, how people, you mentioned that still it is an issue that how people without conflict can live. So these are the two things I thought I shall speak, and again gratitude. It was really a pleasure to see you and to listen you on this forum. Pranam, please. Thank you.
You want me to comment on that one?
Yeah, please, if you can.
You know, any relationship that we build up goes through good times and difficult times. This is the same for Auroville. The aim of creating, we have been given an experiment and adventure to put together a human unity. And there are periods when we manage to move forward on that aim. There are periods where it seems to disintegrate, and whatever we do, whatever good intention we have, it's difficult. We are not exempted from the worldwide forces that are working at that time, at this time, and it's quite a bit of, if you look at the global environment of destruction taking place, chaos, falsehood, and things like that, which are happening. We are not exempted from that one, from that wave. It's a grace that Auroville still exists, that we still believe in it, and that we, despite all the difficulties that human beings which are coming together for a common ideal are able to slowly move forward. That would be my response to that one. Nobody is exempted from the surrounding environment at the moment. We all try to make the best out of a quite difficult world period through which we journey.
Mr. Tency, thank you for your wonderful presentation. All through your presentation, I remembered two aspects which Shri Ramakrishna Paramahamsa, that is Swami Vivekananda's guru, used to mention. He would say the tree which bears maximum number of fruits, it always bends low because of the weight of the fruits as such. So similarly, a person who has real knowledge and real wisdom, he is always humble. That humility all of us could feel, and I think all of us will agree for that. So that humility, it was so wonderful. The second thing is, he always used to tell
that knowledge which helps us to grow, helps human beings or helps the existence to grow, should always be freely given so that the existence will improve, grow, not develop but grow. That's what he used to say. So these 2 points you have wonderfully portrayed through your presentation. And many of the times when the technical details were given, I was not able to follow you. But this is something wonderful, which I personally feel you have succeeded. You were telling you had a lot of challenges, but you as a person has succeeded, and that's what matters. Thank you so much.
Thank you.
Sarve bhavantu sukhinah, sarve santu niramayah, sarve bhadrani pashyantu, ma kaschit dukkha bhag bhavet. Om Shanti Shanti Shanti. Have a wonderful day. Thank you so much.